So from today class, 100% one question for me and one question for IIT is coming. If it is not come, then ask. 100% is coming. So let's get started. Today our topic, a new topic, motion in one dimension, which is a very important and basic chapter to all the physics. This motion we are using in thermodynamics to kinematics and to modern physics also. Everywhere we are using. So it is very important. So let's get started without wasting any time. Myself Tawfiq Naik, and this is a place added where we add some extra knowledge to your brain. So let's get started. So motion in one dimension. This motion in one dimension, it is kinematics. We are discussing kinematics. Okay, kinematics means we are studying only motion. And we are not studying the cause of motion. We are studying only motion. Only motion, not cause. We will study cause in Newton's laws of motion, NLM, where we study why this motion is happening. But this kinematics means a study of motion without knowing the cause. We don't need cause. Okay, now basically this is. Now let us start. In this today class, we are discussing motion, rest, frame of reference, distance, displacement, speed, velocity, and all kind of illustrations. Illustrations means what are the illustrations they are done. In this IIT, we will discuss. Okay, now let us start it. So rest and motion. What do you mean by rest and what do you mean by motion? When an object, if you see something, when you will say it is rest or when you will say it is motion. For suppose you are in a car. Imagine you are in a car. You are sitting in car. Car is not moving. You will say you are traveling from one point to other point. No. When car is moving, then you will say no. Right? So we can say rest when object is not in motion with respect to time. Time is very important. And motion means what? Very simple. Object is in moving or movement with respect to time. Anything which changes its position with respect to time. 1 second, 2 seconds, 10 seconds, 20 seconds. I travel from here to Bangalore in 10 hours. 10 seconds. How can we travel to 10 seconds in Bangalore? No chance, right? So traveling from one point to other point in some time, it is called motion. And we are sitting, nothing is changing. Places is not changing, position is not changing with respect to time. It is called as rest. Okay, now rest and motion, very important. Remember this. And this rest and motion is relative. Rest, see, I will write here. Rest and motion is relative. Now what does it mean? What does it mean of relative? Relative means rest and motion is depend on observer, depend on observer. How? Okay, now let us see. If imagine this is your room, table. Okay, in this table you keep your book. Okay, now that book changing its position no. As time passes, the book is not changing its position. No. If you see standing here, book is not changing position. But the person who is sitting on the moon, he says that this book is moving. How? One observer, you are observer, book is not moving. Other observer, book is moving. How? See, the man who is sitting in the moon, he feels that earth is moving. If earth is moving, he says earth, table also moving. So by this you can say that this motion and rest is dependent on observer, however we choose. And in this entire unit, we choose only one frame of reference. I will tell you what is the frame of reference. Now, okay, let us see. Let us see one more example for rest and motion. And rest and motion is relative. This is very important. Relative. It's depend on the observer. Okay, now depend on the observer. Now there is one more example. Let us see. It is HCR example. Okay, very simple. See here, there is one man. Okay, before that it is a train moving with some speed. Okay, velocity. Now there is a man enter the train, and he is telling, hey, hands up, don't move. If you move, I will kill you. Now he said, hands up, don't move. All other, okay, hands up, not moving, no moving. But there is a person standing out of the box, somewhere outside. If it is a train moving, here, okay, let's say here he is, in villages we say someone sheep, they are taking to sheep for food, feeding them food. Like that, a person standing here and seeing that this train is moving. Train is moving. Array, when this observer one said, according to him, train is not moving. Sorry, everything is in rest. These persons all are at rest. But according to this dirty fellow, they are moving. How? Use this thing. Isn't it beautiful? Yes, it is beautiful. See, same situation, but two observations done by two observers. This is, we say, motion and rest is depend on observation, because now this thief, according to this thief, everything is in rest, but according to this man, everything is in motion. Super. Now let us continue one more thing. Okay, now there are some important points to be noted, my lord. Noted, my lord. Nobody is at condition of absolute rest or absolute motion. I just said now, nobody in this world is condition of absolute rest or absolute motion. Sir, you have become mad, huh? What you are telling, sir? Why nobody is rest, nobody is motion? Array, I think you are in this world, you are in this earth. If you say some point, it is in rest. According to you, it is in rest. But the person is in satellite or moon. According to him, earth is moving. If earth is moving, then the point is moving. Now, according to, so okay, now moon is okay. Now that moon also moving, and moon, earth, this also moving around the sun. Now this sun is moving around the galaxies. See, the galaxies are again moving. So, in this world, nothing is at absolute rest, nothing is at absolute motion. So there is no motion, no absolute rest. And there is one more thing. Rest and motion are dependent on observer. Okay. I explained this point. And without observer, this point is very important. Without observer, one minute. There is no rest or motion. See, without observer, there is no respect of rest or motion. Arey Baba, you are observing. If you are not there, then what is rest and what is motion? If you are not there, then what is rest and what is motion? No, useless. Yes, it is useless. Now, third point, for our consideration, earth is assumed to be at rest. Okay. See, I said now, in this whole chapter, see, normally nothing is in rest, nothing is at motion. But for our convenience, to solve problems, to make easy problems, we take in this whole chapter, earth as rest, until and unless they have mentioned any special case in question. If they mention, say, we are solving about problems only, we are thinking about problems only. So, if they mention in problem that take a place as rest or motion, you will take it. Or else, if they are not mentioned, then you will take earth as rest. Okay, okay, okay. Keep here, keep here, keep here. Okay, 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 okay. Now, frame of reference. Now this is okay. Motion and rest clear. Motion and rest clear. We will discuss problem. Beautiful problems. Don't worry. Now frame of reference. What is this FOM? FOM. 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 Okay. Okay. I will explain you very clear. See here. I suppose this is a person. Okay. Me, or let's say Suleiman Bhai. Let's say, Suleiman Bhai. Now, from this distance to somewhere distance, 20 kilometer away from Suleiman Bhai, here our Vaishwarya is there. Vaishwarya. Vaishwarya. Now, Suleiman Bhai. How can he say that she is that much distance? We know 20 kilometers. In what direction? 20 kilometers where? Vaishwarya is 20 kilometers from Suleiman Bhai. What? No sense. Right? Now, my home and school 20 kilometers. What 20 kilometers? Where 20 kilometers? Your mind. Now, one more thing. If here is a, let's say, insect. Now, that is also, insect is also 20 kilometers or 20 meters. Okay, 20 meters. Then this Suleiman Bhai, I got an idea, man. I got an idea. Okay, what is that idea? Let's take here a deer. How to write deer? Suleiman Bhai, careful, it is deer. 20 kilometers above deer. Above. Now 20 meters, 20 kilometers. What is this 20 meters, 20 kilometers? How to measure? How to say? That time, to understand this, we come to a new topic, frame of reference. In this frame of reference, now what we will do, see, a frame of reference, it is a Cartesian coordinate. Frame of reference means three coordinates, three perpendicular coordinates right here. Three perpendicular coordinates. Very simple. Okay. Now let us, three perpendicular x-axis, y-axis, z-axis. Now, vectors we are discussed. Whatever the x-axis, we will say it as I, minus x-axis, minus I, z-axis, I, j, minus j, k, minus of k. Now, how to read? Whenever in this point, origin, we take observer. Origin, observer. Suleiman Bhai. Origin, observer. From here, always observer. Okay, now it is a point from here, everything is observed. See, very simple. I am standing here. From this side, x-axis, y-axis, z-axis. So whenever I want to read. Now this is Suleiman Bhai, and this is Vaishwarya Bhabi. Now we will read Vaishwarya Bhabi is 20 kilometers away or far away in x direction. Now if this Suleiman Bhai wants to reach this Vaishwarya, he wants to walk 20 kilometers in x direction. Now if this Suleiman Bhai wants to catch this, then he must travel 20 meters in y-axis. Okay, remember this. Whenever they ask, you must chill, relax mode. Very simple. Now, if he wants to catch Vaishwarya, he wants to talk 20 kilometers in x-axis or x direction, positive x direction, Now, to catch deer, he must walk 20 meters in y direction. Similarly, minus x direction this side, minus y direction this side. Okay, this is basically frame of reference how we read, and what is the full frame of reference. That's all. Okay, and very simple, three perpendicular axes, three mutually perpendicular axes, which is called as Cartesian coordinates. Cartesian coordinates. Okay, write it here. I will write here. Wait. Cartesian coordinates. Cartesian coordinates. Okay, now Cartesian coordinates. Very simple. When this Suleiman Bhai wants to meet Vaishwarya, he must travel 20 kilometers in x-axis. Okay. Now, if this Vaishwarya wants to meet Suleiman Bhai, then she must travel 20 kilometers negative of x-axis. Okay. Simple case. Okay. Very simple. This is frame of reference. Now frame of reference. Now there are three kinds of frame of reference. Three kinds of motion. Three kinds of motion or three kinds of frame of reference. Okay. We call it. Okay. Now see. First of all, motion in one dimension, motion in two dimension, motion in three dimension. Now for suppose, let's say this is road, and this is your car. Okay, this is your car. Now it is moving with some speed. Whatever speed, let's say it is moving with some speed v. Now it is traveling in only one path. Motion only in one axis. See here, one axis, motion only in one axis. We know Cartesian coordinate, anything is changing its position, we call as motion. Now it is at this position, it's moving this position to this position. Only one axis is changing. Is there any change in y axis? No, only x axis changes there. So whenever a motion is in only one axis, motion is in one axis is called motion in one dimension. Okay, super. Very simple. For example, a car is moving, cycle is moving, you are moving, only one direction you will see. You will move in only one direction. Tick, 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 tick. Can you move like this? X, Y, tick, 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 tick. No? No? Okay. One dimension, it's okay. Now two dimension. What is this two dimension? Change in two axes. One axis, two axes. Now, I will write definition. Motion is in two axes is called as change in two axes. Motion is in two axes. Whatever. Change in two axes is called as motion in two dimensions. Okay, what an example. Okay, now it is football. Let's say it is football. Now a person is kicking this. Now this football moves like this, right? Moves like this. Now if I draw axis, see here, x-axis at this point, x-axis changing, y-axis changing. At this point, x-axis changing, y-axis changing. X-axis changes, y-axis changes. Now, if we draw the line like this, in any instant, x-axis is changing, y-axis is changing. X-axis is changing, y-axis is changing. Both axes changing. Then it is called as 2D motion. And this is we'll discuss in plane, 2D dimension. Plane, motion, projectile, everything. Okay, man? Okay, don't worry. Very simple thing. Very simple. Now one more last thing. Now, last thing, 3 dimension. Array, sir, ball moving is a 3 dimension la. Sir, you said football kicking. That is 3 dimension ah. Then how it comes to 2 dimension? Any doubt? Array, fools. See, football is kicking. Football goes like this. See, I will write here. Football goes like this. At any instant, if it is going like this, covering y-axis and x-axis, if this football goes like this, if it is going smoothly, x and y. If it is going y, z-axis, everything is there. But football is not moving like that. Football is not moving like that. Okay. I want 3 dimension. 3 dimension is very simple. Three axis also changing. Now example, sir. Example. Okay, let us take a kite. Alright. Now tell me how many of you use these kites? Okay. Now kites will go into sky. And they won't go in one direction. They won't go like this. They will like many direction, n number of direction. First they may go stright, then again they may go y-axis. Suddenly they may come z-axis. Kite. How to draw kite, man? Okay, kites. 3 dimension. Very simple. Okay, now. Okay. Now, next one. Distance and displacement. Very important and very simple. What do you mean distance and what do you mean displacement? See, just imagine you are starting a journey from your home. You are leaving the home and going to your school and returning to your home. That's all. Now the total distance is there. Total displacement is there. That's all. For suppose, imagine this is your home. Okay, home. Yeah, perfect home. Now this is your school. Now you will leave from home here. Now let's say your route is like this. Okay. Now to distance from here to here, let's say total path, let's say 20 kilometers. Okay. You went from your home to school, 20 kilometers. Now at this point, your distance is 20 kilometers, and displacement here, displacement is the shortest distance from your home to your school. See, for any there is shortcut, shortest distance and long distance. Now that long distance, full distance is not, that is called distance, and shortest distance. See, if I draw a shortest distance from here to here, this is your displacement and this is your displacement. Okay. Now one more thing. If you go evening from your school to your home again, now distance become 40 kilometers, but displacement becomes zero. Displacement becomes zero. Displacement becomes zero. Beautiful. See, very simple. Distance means actual path. Whatever the distance, whatever the road you are covering, actual path. But displacement means distance between initial and final. Starting, ending. Displacement means distance between starting and ending. Very simple. See, from morning when you leave your home to school, 10 kilometers, 20 kilometers is there. Initial point, final point. Now when you return, initial point, final point same. Then displacement becomes zero. See, distance is actual path. Displacement is minimum distance between initial and final point. Sir, salute, sir. Okay. Now there are some properties which are very important. Let us see some properties. For a moving body, distance is always increasing. See, I will explain here. If it is a body, it is moving like this. Maybe it comes reverse. Distance is total path. If it is 10 kilometers, if again it is 10 kilometers, right? Total becomes 20 kilometers. There is nothing decreasing. So when the body is moving, distance is always increased. But displacement is not like that. Displacement can be increased, can be decreased. See, I will explain here itself. How? Okay. See here. Now, if this boy travels up to here, 10 kilometers distance, displacement increase. Now if you take little U-turn, now this short initial and final position distance decrease. Now if we travel much more near, again decrease initial and final point. See, initial and final point distance decrease. So we can say displacement can be increase or decrease. Increase or decrease. And next point, for a moving body distance is always positive and never be negative or zero. Positive and negative zero. Yeah, this point is very good. Very good. Very good. Now I will explain this very clear. Don't worry. See, you just imagine there is no place. Okay, if this is a boy, he's moving like this, yes, and if he turns like this, distance is same. If it is 10 kilometers, and if it is 10 kilometers, distance becomes 20 kilometers. Now if again you travel somewhere here for 5 kilometers, your distance becomes 25 kilometers, right? So distance can never be zero. Distance is actual path now, so it is always added, positive. But if you come for displacement, it can be negative, can be positive, can be zero. How? See here. Now if this boy was at this point, displacement is positive. Now if we take U-turn, comes to here, initial point, displacement is zero, initial point minus final point, displacement becomes zero. Now if we go backside 5 kilometers, then what happens? Final position minus initial position becomes, use this negative. See, distance, displacement can be negative, positive and zero also. Okay, if the distance is zero, then body is said to be at rest. If distance is zero, body is said to be rest. No need to explain. See, if it is a body, it is not. If it is move, it covers distance. But if distance is zero, then body is at rest. It is not moving. Now if displacement is zero, that is either body is at rest, or either passing through the initial point. See, I explain here, passing through the initial point, initial minus final, final minus initial becomes zero now. So now last time, there are infinite value of distance between two fixed points. There are only one unique value of distance between two fixed points. Very simple. Say this distance has infinite number of values. If you break it small, it becomes infinite number of values. But for displacement, it is not only one unique value. Okay, fine. Now let us see one basic, very simple question. I think you will answer very quick. Okay, a boy completes one round of circular track. Okay, read one round of circular track of radius 20 meters in 50 seconds. Okay, then displacement at the end of 4 minutes 10 seconds. Say, first understand the question. They are telling, boss, there is one ground. It is ground. It is ground. Okay, adjust now. Okay, it is a ground of 20 meters. Now there is one boy who can cover this ground in 50 seconds. Now boss, at 4 minutes 10 seconds, what is the displacement of this boy? Displacement is what? Distance between initial and final position. Final position minus initial position. Shortest distance between final and initial. Okay, you can say this. Shortest distance between final and initial. Okay. Now, see, let us write this all in seconds. 4 into 60 plus 10. 4 6 are 2400 plus 10, which is equals to 250 seconds. I think many have got their answer, but also one time. See here, one circle, you go like this, 50 seconds, and again second circle, 50 seconds, which means third circle, One more circle, fifth circle. Oof, fifth circle. See, now 250, your total distance, total second, he's taking 50 seconds for one, 50 seconds for one, which means how many circles can he be? One's up, five up. So 5 circles he will rotate, 5 circles he will cover, 5 circles he will cover. But see, covering one circle, 50 circle, again 50, again 50, again 50. That's all. Which means displacement becomes 0. Displacement becomes 0. Displacement becomes 0 because he is taking 50 seconds to calculate, 50 seconds to rotate 50 seconds to move one circle, and he is going 5 circles, and he is coming to that point, becomes 0. Right? Yes, I know. Okay, now see, this is very important. How to write this displacement in unit vector type? Okay, very simple. I will make it as very simple. Condition, that is a condition in one dimension. Okay, condition in 1D, condition in 1D. Okay, now let's say a body traveling like this. Okay, now distance, it is like r1, vector r1, at middle vector r2, at this point it is say vector r3, points a, b, c. How to demonstrate this? How to write this condition for 1D? How to get this answer? How to get this distance, AB distance, BC distance? Very simple. See, very simple. We know this one. And here, you need to remember one thing while dealing with AD and uniform motion. See, at this condition, your AB vector is equals to your BC vector. So what can you write? You can write like this. This is minus. This is minus. Okay. Now you can easily calculate distance by magnitude. Very simple. Conditions for 1D. Remember this. This may be useful. Maybe not. It is useful. Array, this one understood. What I am trying to say. Very simple. One more time I will say. See here, one more time for you guys. I will tell you. Now there is a person who can travel one circle of ground in 50 seconds. One circle of ground is 50 seconds. Which means he is starting here and coming here. Displacement becomes 0. Displacement at this point becomes 0. Now total distance, total time he run is 250 seconds. At 50 seconds, it is coming to initial point, becomes 0. Again 50 seconds, initial point 0. Again 50 seconds, initial point 0. Again 50 seconds, 0. Again 50 seconds, displacement 0. Okay, now I think now it's clear. Okay. Now there is one more question. See, this is very important question. Sorry, everything is important. Yeah. Okay. An insect starts climbing a conical birthday flag hat of radius 5 meters. At a base, it starts from point A and reaches point B, taking a spiral path on the hat. Find out the displacement of the hat if height is 12 centimeters. Now, I know many of you didn't understand. See, there is a birthday cone which you keep here now, birthday cone, whose height they are given is 12 centimeter, and radius they are given 5 centimeter. Now there is an insect here. It's taking spiral path like this. Okay, I will change the color. It's taking spiral path like this. And reaching here. Spiral path. And reaching. Now we want to tell what is the displacement between point B and point T. Point B and point T. See, this is very simple case, very simple case, very simple case. Now this is 1 minute. Okay. Now it is height. There is insect like this here. Here is insect. Here is insect. How to calculate? Now if it is like this, it is like this, it is like this. If I turn like this, it becomes like this. Like this. Now insect is here at 5 centimeter and this is 12 centimeter. Now insect must shortest distance insect must come here and go upside. Now displacement, it is this displacement. Very simple. Now basically you think, what you think, if there is insect at A point, B point, it can go to A point in 12 centimeter. Array, no, see it is like this, it is like this, insect is here, insect is here, insect is here, not exactly here, insect is here, so it must come here, go here. If it is insect here, it go like this, but insect is here, it must come here and go here. So very simple. Now Pythagoras theorem, very simple. 12 का whole square plus 5 का whole square, 144 plus 25, whose square root becomes 30. Shortest distance is 13 meters, 13 centimeters, 13 centimeters. Simple case needs simple solution. Okay, now SI unit, speed. What do you mean speed and SI unit? We will see. Speed is very simple. Now we discuss distance and displacement. With respect to time, it is called speed and velocity. Speed means distance divided by time, or total path length divided by total time. Very simple. Now here you are a boy starting your journey, going like this or going like this, like this, like this. If it is 10 kilometers and if it is 20 kilometers and you are taking 1 hour of time, 1 hour of time, for suppose you are taking 1 hour of time, then speed is equals to total distance 10.20 divided by 1 hour, 10.20 divided by 1 hour, so 30 kilometers divided by 1 hour. That's all. You can say your speed was 30 kilometer per hour. Very simple. Okay. Now SI unit, very simple. Distance meter divided by time second. Dimension very simple. Meter, dimension MLT, right? Dimension. Now mass, there is no mass. Length is there. Time is there. Okay. Now average speed. Average speed is also same. Very simple. Average speed is total path of length divided by total time taken. That's all. And you can write this as dou S divided by dou T. Average speed is very simple. Total path you cover from your home to your school divided by time. How much you take? That's all. Okay. Now, if we come to instantaneous speed, this is very tricky to understand, and we will make you expert in this. Don't worry, expert. Now, see, if it is your home, okay, if it is your boy, and you are traveling like this, to your home. Okay, at a particular instant, instantaneous is at one point, at one point, at one point, at one point, let's say this point, at this point, at this point, what is your speed? At this point, what is your speed? At this point, or say, at this point, what is your speed? Instant. See, now normally, if you take this outside, you will cover this distance in let's say 1 second. If you cover this distance in 1 second, now this is there now. In that also small point, you are covering at what time? What? Wait, I know you are not clear. I will explain once again. See, very simple. Instantaneous speed means speed of object at a small instant of time means, see, if this distance you covered in 5 minutes, t is equals to 5 minutes, then at this small point, what was your speed? Small point, let's say a very small point, what was your speed? अरे बोलने का मतलब वेरी सिंपल है यार, छोटे से स्पीड, छोटे से टाइम में 0.001 पॉइंट ऑफ टाइम, व्हाट इज योर डिस्टेंस? दैट्स ऑल. Say very simple. Average distance, speed is equals to total distance divided by time. We know this one. Now if your distance becomes almost near to zero, time becomes almost near to zero. Now see, in this 5 minutes we calculated. Now this time it becomes 0.0000000000001, which is a dot. At that time, what was your speed? That we call as instantaneous speed, and it is written as ds by dt. I will explain you clearly one more time. बोलने का मतलब वेरी सिंपल है, समझने वाले समझ गए, नहीं समझने वालों को अब एक बार बताऊंगा. इतना क्या करूँ, हाँ ये इंग्लिश मुझे आती नहीं. Okay guys, see this, now it's very serious. If it is a car, okay, now it is moving here, now it is moving here. This is point, it has to cross. There is some point it has to cross. So let's take this point. It's take time to cross 5 seconds. This car take time to cross 5 seconds. Okay. Now 5 seconds is okay. Now what was the speed of car at this 1 second, 1 point, where time was not 1 second, where time was 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 What was the speed? It is called as instantaneous. Instantaneous speed. That's clear? Understood? Super? Can I move? Yes. Yes, I think so clear. If it is not clear, tell me. Now uniform velocity. Uniform velocity. One second. Hey, this is uniform acceleration, uniform speed, man. Uniform speed and non-uniform speed. What do you mean uniform speed and non-uniform speed? Very simple. Particle covering equal distance in equal interval of time. Particle covering unequal distance in equal interval of time. Very simple. Now see, if it is your particle, and it is your distance, full distance. Now this is 1 meter. Let's say this is 1 meter, and this is 1 meter. This is meter, and this is a meter, and this is a meter. Similarly here, let's say it is a particle. Now it is full distance. It is 1 meter. It is some meter distance covering. Okay. Okay. It is some distance. It is some distance. If it is 2 meters, if it is 0.5 meters, if it is 10 meters, 10 meters. Now the same thing is uniform distance is particle covering equal distance, 1 meter, 1 meter, 1 meter, 10 meter, 10 meter, 10 meter in equal interval of time. For suppose it is 1 second, 1 second, 1 second, 1 second. See, in this, time for every interval is same. Time for every interval is same, and distance is also same. This kind of motion we call as uniform motion. Particle covering equal distance in equal interval of time. Very simple. Now come to this side. Particle covering unequal distance in equal interval of time. Once again, 1 second, 1 second, 1 second. See here, time is same, 1 second, 1 second, 1 second, 1 second. But distance is 1 meter, 2 meters, 0.5 meters, 10 meters. So you can say time is same, but distance not equal, is called as non-uniform time, non-uniform speed. Okay, now non-uniform speed. Okay, clear. Can I move? Okay. Now, there are few things to be done in this class. Okay. See here, particles traveling distance s1, s2, s3, etc. with the speed v1, v2, v3, etc. Then in the same direction, this is important, same direction. Then the average speed. Sanyanji. How? See here. Average speed is equals to what? Distance. Total distance, right? Total distance divided by total time. Right. Now here they are given distance. Okay, fine. They are given distance s1, s2, s3 up to n number, sn, and they are given no time. Basically, this is our formula. But where is time? Now this is the function. See, this kind of questions, they may arise in your exams. They will arise in which distance is given, velocity is given, time is not given. Distance is given, velocity is given, time is not given, but set to find average velocity, average speed. If it is in straight line, average velocity, average speed, both are same equation. If it is in straight line, okay. Now how to see? How can we do? Come here. See, very simple. Velocity v1 is equals to s1 t1, right? Velocity v2 is equals to s2 t2, right? Can I write this as t1 is equals to s1 v1, and this is t2 is equals to s2 v2? Yes. Now can I substitute this side? s1 plus s2 plus s3 plus n number sn divided by s1 divided by v1 plus s2 divided by v2 plus s3 divided by v3 plus n number plus sn divided by tn. Right? Super right. Now, this is clear. This is clear. Now let us take only for two cases. Let us take 2 points. Let us take 2 points. I will explain what they are telling. See, man, they are telling very simple. It is an object. It is object. Now object, it is like this. Like this. Now, baby doll. It is distance 1. It is distance 2. It is distance 3. N number. It is distance 3. Up to n number, it is distance n, and at this distance velocity is v1, velocity is v2, velocity is v3, n number, velocity is v1. Now time is not given. Calculate time and tell what is the average velocity. That is the average velocity. Easy thing. It was easy thing. So we did very easy. Now we don't know time. So time is equals to s1 divided by v1. We write time 2 is equals to s2 divided by v2. Time 3 is equals to Sn divided by Vn. Now, if you consider only 2 cases, if T1 S1 is equal to S2, then I can say 2S is equals to S 1 by V1 plus 1 by V2. This one get cancelled. Totally 2 divided by V2 plus V1 divided by V1 V2. Finally I will get 2 times of V1 V2 divided by V1 plus V2. If they are given only distance and velocity, then this is the case. There is one more case we will discuss. See, at this point they are given distance particle traveling the speed v1, v2, v3 etc. during time t1, t2, t3. Average velocity. Now they said v1 given, v2 given, time given, but distance is not given. v1 given, v2 given, v3 given, up to some vn given. Time t1, t2, up to tn given, but no word for distance. How can we do? Very simple. We know average velocity is equals to s1 plus s2 plus s3 plus up to n, s of n, divided by t1 plus t2 plus 3 plus up to t of n. Very simple. Now they are not mentioned about anything about s. So can I write it as like this? v1 is equals to s by t1, then s1 is equals to v1 t1, v2 is equals to s2 divided by t2, then s2 is equals to v2 into t2. Yes, I can write. Now finally what I can write? I can write like this: v1 t1 plus v2 t2 divided by t1 plus t2, t1 plus t2, average speed. Now if t1 is equals to t2, then can I write like this: v1 t plus v2 t divided by 2t, which implies t v1 plus v2 divided by 2t, tt get cancelled. Now remains is v1 plus v2 divided by 2. This is for 2 points. If you take for 3 points, v1 plus v3 divided by 3, v1 plus v2 plus v3 divided by t, if we take for 3 points. Now in this case, if we take for 3 points, it becomes like this: 3 times of v1 plus v2 divided by v1 v2 plus v2 v3 plus v3 v1. Okay. So I hope you understand this. If you are not understand, let me know. I will clear it. Okay. We will meet in the next class. Until that, thank you. Bye bye. Tata. We will discuss velocity and problems in the next class.